Nanotechnology. What is it? Is it useful? And what are its applications in this highly technological era? To find out more, watch this video. Hey guys, I'm MJ Sanga, your creative engineer. Now, nanotechnology. It's not new, but it has made technological advancements over the years. We can define nanotechnology as the manipulation of matter in a near atomic scale to produce new structures, materials, and devices. Nanotechnology promotes scientific advancement in many sectors, such as medicine, consumer products, energy, materials, and manufacturing. Now, you may have watched many movies, shows, anime, and cartoons that have shown cool ways of using nanotechnology. However, nanotechnology refers to engineered structures, devices, and systems. Nanomaterials have a length scale between 1 and 100 nanometers. At this size, materials begin to exhibit unique properties that affect the physical, chemical, and biological behavior. These nanomaterials are made of what we call nanoparticles. These particles can be made from a wide range of materials such as metals, metal oxides, polymers, and dendrimers. Synthetic nanoparticles can be used in a wide range of applications such as electronics, energy, and medicine. This is because they have unique properties which mostly come from their small size and high surface area. The basic principle of this technology is possible for two reasons. Firstly, nanomaterials have a relatively larger surface area when compared to the same mass of material produced in a larger form. This can make materials more chemically reactive. In some cases, materials that are inert to their larger form are reactive when produced in their nanoscale form, and they can affect their strength or electrical properties. Secondly, so-called quantum effects can begin to dominate the behavior of matter at the nanoscale, particularly at the lower end. This affects the optical, electrical, and magnetic behavior of materials. So then, how did this technology actually start? It all started with American physicist Richard Feynman, who was considered the father of nanotechnology. He introduced the ideas and concepts of nanotechnology in 1959 in a talk titled "There's Plenty of Room at the Bottom." However, modern technology actually began in 1981. This began when the scanning tunneling microscope allowed scientists and engineers to see and manipulate individual atoms. IBM scientists Gerd Binning and Richard Rohr won the 1986 Nobel Prize in Physics for inventing the scanning tunneling microscope. The Binning and Rohr Nanotechnology Center in Zurich, Switzerland continues to build on the work of these pioneering scientists by conducting research and developing new applications for nanotechnology. The iconic example of the development of nanotechnology was an effort led by Don Egler at IBM to spell out IBM using 35 individual atoms of xenon. By the end of the 20th century, many companies and governments were investing in nanotechnology. Major nanotech discoveries such as carbon nanotubes were made throughout the 1990s, and by the early 2000s, nanomaterials were being used in consumer products from sports equipment to digital cameras. By the way, if you're enjoying this video, please hit a like and subscribe. Now, nanotechnology has many applications, not just in the engineering industry. For example, nanotechnology in medicine. The medical advances that may be possible through nanotechnology range from diagnostic to therapeutic. In diagnostics, the ultimate goal is to enable physicians to identify a disease as early as possible. Nanomedicine is expected to make diagnosis possible at the cellular and even subcellular level. In terms of therapy, the most significant impact of nanomedicine is expected to be realized in drug delivery and regenerative medicine. Nanoparticles enable physicians to target drugs at the source of the disease. This increases efficiency and reduces side effects. Next, we have nanobiotechnology. Physicists, chemists, and biologists view nanotechnology as a branch of their own subject, and collaborations in which they equally contribute are very common. One result is a hybrid field of nanobiotechnology that uses biological starting materials, biological design principles, or has biological or medical applications. Combining biotechnology and nanotechnology could, for instance, lead to molecular prosthetics. These are nanoscale components that can repair or replace defective cellular components, such as ion channels or protein signaling receptors. Another result would be intracellular imaging to highlight early disease markers in routine screening. Lastly, let's not forget the application of nanotechnology in the manufacturing industry. Nanomaterials have to meet the demands of facing new structural materials, reduced energy consumption, and reduced life cycle costs. Advances include reduced fuel consumption and operating costs, reduced or zero emissions, improved capacity, and reduced life cycle costs. Breakthroughs in nanomaterial engineering depend on how precise we can see the relevant structures and how they can change during the process. This in turn puts serious demands on tailored analytical tools ranging from diffraction, imaging, microscopy, tomography, and so on, with the highest spatial resolution of less than 50 nanometers. Many applications of nanotechnology involve new materials that have different properties and new effects compared to the same materials made at larger sizes. This is mostly due to the high surface ratio of nanoparticles compared to larger particles, as well as to effects that are seen in small scale but cannot be seen at large scale. There are so many advantages of nanotechnology, and with the development of technology over the years, the possibility of nanotechnology is endless. If you enjoyed this video and you want to learn about automation, you can click the link right here. Or if you like this video and you want to learn about PCB boards, you can click the other link right here. By the way, don't forget to like, subscribe, and also share this video to let your friends know about nanotechnology. I hope to see you again in the next video. Have a great week.